Hey guys, how are you today? So today I'll be explaining chapter 4 of the chemistry notes, only the questions, because literally there's nothing to explain. It's all about methods and about the equation N equals C times V. And that's pretty much it. It's 6 pages if I'm not mistaken until page 20. Yeah, so not 6 pages, 5 pages, so from page 14 until page 19. So let us start with the first page. It says that we have CQD number 2 first. They said what mass of H2SO4 is needed to prepare 500 centimeter cubed of a 2 molarity solution. First of all, we have what? We have our volume, but our volume always needs to be in liters. As you can see, we have it in what? We have it in centimeter cubed. So to change it from centimeter cubed into liters, we are going to divide by what? We are going to divide by 1,000. So very simply, the volume in liters is what it is, 0.5 liters. And we also have what? We have our concentration, which is 2 molarity solution. They told us what? What is the mass of H2SO4 needed to prepare this? First of all, in order to find the mass, we need to think of any equation that has mass. For example, mass over molar mass is equal to what? Is equal to the number of moles. Then, next, let's think of another equation that includes what? That includes the volume and the concentration and number of moles. Very simply, it is what it is, N is equal to C times V. So N and N are the same thing. So very simply, you can substitute them and you will get what? You will get that the mass over the molar mass is equal to what? Is equal to concentration times volume. So if we're looking for the mass, then you'll have to move molar mass to the other side. That means mass is equal to concentration times volume times molar mass. Now for the mass of H2SO4, usually they might give it to you. If they don't give it to you, you will have to use the calculator. So it's gonna be 2 times 1 plus S. How much is S? S is 32 plus 16 times 4. So 2 times 1 plus 32 plus 16 times 4. So you will get an answer of 98. So 98 is what? 98 is the mass of H2SO4. Or not the mass, it is the molar mass, capital M of H2SO4. Okay, now as you can see, we have what? We have everything we need. We have the molar mass, we have the volume in liters, and we have our concentration. Remember to make everything into its scientific unit, okay? So in this case, to find the mass, it's equal to the concentration, which is 2, times the volume, which is 0.5 liters, times what? Times the molar mass of H2SO4, which is 98. So you're gonna get what? You're gonna get that the mass is what it is. If you put it on the calculator, 2 times 0.5 times 98, it is what? It is also 98 grams. Okay, so that is it for part A. We will move on to part B. In part B, they said what? 25 centimeter cubed. Remember, whenever you see it in centimeter cubed or milliliters, you will need to change it into what? Into liters or decimeter cubed. Okay, so very simply, we will need to change it into liters if it's centimeter cubed or milliliters. So how do you change it into liters? Very simply by dividing by 1,000. So this is gonna be 25 divided by 1,000, which is what? Which is 0.025 liters. Then we also have what? We have the molarity, which is, or the concentration, which is 0.400 molarity, or evaporated to dryness. And we have what? We have the mass of the salt. And they want us to find what? They want us to find the molar mass, capital M. So again, you're going to write the two equations that we know. We know that mass over molar mass is equal to N, the number of moles. We also know that N is equal to concentration times volume. So we will substitute. That means mass over molar mass is equal to concentration times volume. So you have to take everything in SI unit. We are looking for what? We are looking for the molar mass. So how can we keep the molar mass in, as it is the subject of the whole equation? You will just switch the places with concentration times volume. So the mass over concentration times volume is equal to the molar mass. Now you just substitute. What is the mass? The mass in this case is 1.11 over the concentration, which is 0.4 molarity, times the volume, which is 0.025 liters. So put it all on your calculator. And you're supposed to get an answer of 111 grams per mole. So this is the molar mass of the salt. We'll move on to part C. What does it say in part C? In part C, it says what volume. So we need to find the volume of 2 molarity. This is the concentration. of HCl. This, remember, HCl, we can find its molar mass. What's the molar mass of HCl? It is H1 plus Cl, which is 35.5, so it's 36.5. This is the molar mass of HCl. Okay, it's 36.5. It contains how much grams? What is the mass? It is 3.65 grams of solute. So very simply, we'll write the two equations. Mass over molar mass is equal to number of moles. Number of moles is equal to concentration times volume. That means mass over molar mass is equal to concentration times volume. If we need to find the volume, then very simply you will have to move the concentration to the other side. So it's gonna be mass over molar mass divided by the concentration is the volume. So very simply it is what? It is mass over molar mass times concentration is equal to the volume. Right, so let us substitute the mass that we have, it is 3.65, over the molar mass, which is 36.5, times what? The concentration, which is 2. And you're gonna get your answer, which is 0.05 liters. Remember, here in this case, they didn't specify, but if they specified and they wanted it in centimeter cubed or milliliters, you would very simply multiply by 1,000, so times 1,000, okay, to become what? Centimeter cubed, so it is 50 centimeters cubed. Okay, so we will move on to CQD number 3. What does it say in CQD number 3? It says a sample containing 2.12 grams of Na2CO3 was dissolved in, okay, first of all, this is what? This is our mass. Was dissolved in 500 centimeter cubed, so this is our volume, but we will need to change it to liters, so you will divide by 1,000, so you will get 0.5 liters. They wanted what? They wanted us to calculate the concentrations of all ions present in the solution. Okay, so we're dealing with what? We are dealing with Na2CO3. So we're dealing with what? We're dealing with Na2CO3. So let's see how many ions we have. If you separate them into their original ions, you have Na plus and CO3 2 minus. But as you can see, we have what? We have 2 negative and 1 positive. It does not balance. So in order to balance it, you'll just put a 2 over here. So how many ions do we have? We have 2 Na plus ions and 1 CO3 minus, CO3 2 minus ions. Okay? Now that we have the number of each of the ions, okay, like 2 Na plus ions, 1 CO3 2 minus ions, we will need to find the concentration of Na2CO3 in general. So how do we find the concentration together? We have mass. We can find the molar mass of Na2CO3. Let us find it together. Na, it is 23. So 23 times 2 plus carbon 12 plus 16 times 3. So 23 times 2 plus 12 plus 16 times 3. That will be an answer of what? Of 106. So now we have what? We have the mass, the molar mass, and the volume. It's left us to find the concentration. So mass over molar mass is equal to number of moles. Then number of moles is equal to concentration times volume. So that means very simply what? Mass over molar mass is equal to concentration times volume. Okay, so let us take everything that we have. The mass, which is 2.12 grams, over, oh my bad, I forgot to continue. So we need to find what? We need to find the concentration. So you'll move volume there. So it will be mass over molar mass times volume is equal to the concentration. Okay, so let's find the concentration together. Okay, so let's find the concentration together. We have the mass, which is 2.12, over the molar mass, which was 106, times the volume, which is 0.5. So put it on the calculator. It's gonna be 2.12 over 106 times 0.5. So it's gonna be what? It's gonna be 0.04 molarity. Now we have the concentration of what? We have the concentration of Na2CO3. So 1 Na2CO3 will give us 0.04 molarity. Right? So 1 Na2CO3 will give us 0.04. What does this mean? This means if we have 2 Na plus, it's gonna give us 2 times 0.04 molarity, which is what? Which is 0.08 molarity. In the exam, put it based on what they want you, like the number of significant figures. And here it's gonna be 1 times 0.04, which is what? Which is 0.04 molarity. So that is it for CQD number 3. Let us move on to exercise 1. What does it say in exercise 1? We have AlCl3. Let us separate it into what? Let's separate it into its ions, which are what? Which are Al3 plus and Cl minus. As you can see, it's not balanced because we have what? We have 3 positive and only 1 negative. So to balance it, you will put a 3 over here. Okay, so now we have 1 Al3 plus, but 3 Cl minus, right? So they told us what, that Cl minus, 1 Cl minus will have a concentration of what? It will have a concentration of 0.2 molarity. So let us find the concentration of Al3 plus. If 1 Cl minus has a concentration of 0.2 or 0.20 molarity, then for sure what, 3 Cl minus will have a concentration of what? It will have a concentration of 0.20 divided by 3, which is what? Which is 0.067 molarity. Now, because this and this are balanced, that means if this gets 0.067 molarity, then this gets what? This will get 0.067 molarity. So the concentration of Al3 plus is what? Is 0.067 molarity. Let's move on to, okay, so they said what mass of this is needed to produce this. First of all, you will change this to liters, so you will divide by 1,000. 200 divided by 1,000 is 0.2 liters. Then you have what? You have the concentration is 0.25 molarity. So it's gonna be 0.2 times the concentration, which is 0.25. So we will get what? We will get the number of moles. Why did we do this again? N equals C times V. You have volume, you have concentration. So number of moles is what? It is 0.05 mole. Okay? Now, what you need to know is that the number of moles of CuSO4 5H2O is gonna be the same exactly as this one. So that means this has a number of moles, what? 0.05 moles. So if they're looking for the mass, then very simply you'll have to apply the equation. Mass over molar mass is equal to number of moles. So mass is equal to number of moles times the molar mass. So 0.05 times the molar mass of CuSO4 5H2O. It's gonna be what? It's gonna be Cu, which is 63.55, plus S, which is 32, plus 5H2O. So you should know that the molar mass of H2O is 18, if I'm not mistaken. So 18 times 5 is what? 18 times 5 is 90, and my bad, I just realized that I forgot to find the molar mass of oxygen. So it's gonna be 4 times 16, which is what? Which is 64. Now add them all together. So 0.05 times 63.55 plus 32 plus 64 plus 90. Okay, you will get what? You will get that the mass, let's say we wanted to 3 significant figures, because everything is actually 2, because the smallest one is 2 significant figures. So let's say we wanted to 2 significant figures, it's gonna be mass is approximately equal to 12 grams. But however, if you wanted to round it properly, it would be what? It would be 12.48 grams. Okay, so this is what the actual answer is. Okay, so that's exercise number 2. We will move to exercise number 3. 150 milliliters, directly change to liters, so 150 divided by 1,000, that's gonna be 0.15 liters of 0.500 molarity. This is what? This is our concentration. It was mixed with 250 liters. So again, you will divide by 1,000 to get it in liters. So 0.25 liters of 0.300 molarity. So this is the concentration. Okay. So this one is what? This one is NaOH, and this is BaOH2. They said, what is the molarity of OH minus in the final solution? So very simply, what I suggest, or what I think we're supposed to do in this case is what? Is step 1, find total number of moles, total N of OH minus, and then step 2 is to what? Is to find concentration based on number of moles. So first thing we're gonna do is we're gonna find the total number of moles of OH minus. So let's start first of all with NaOH. Let us find the total number of moles of NaOH. It's very simply the concentration times the volume. So 0.15 times 0.5, that is what? That is 0.075 moles, right? So now we have the number of moles of what? Of NaOH. So let's separate it into its ions, Na plus, OH minus. So 1 NaOH gives us this, so 1 Na plus will give us also this, and 1 OH minus is also gonna give us this. So this is the first number of moles we're gonna take, which is 0.075. Now for this one, we're gonna do the same exact thing, right? So we're gonna take the volume, 0.25 multiplied by the concentration. We will get what? We will get that 1 BaOH2 will give us what? Will give us 0.075 moles. But if you separate it into its ions, you will have what? You will have one Ba2 plus and one what? Two. My bad, you will have two OH minus in order to balance it. So if 1 gave us 0.075, then 1 will give us 0.075, and 2 will give us 0.075 times 2, which is what? Which is 0.15 moles. Now, the next step we're gonna do is we're gonna add the total moles. So you're gonna take this and you're gonna add them together. So 0.15 plus 0.075, you will get an answer of 0.225 moles. This is the total number of moles of OH minus in the solution. Now that you have the number of moles, let's add both volumes together. So 0.15 liters plus 0.25 liters. That's gonna be what? That's gonna be 0.4 liters. Now that we have the total volume and the total number of moles, we can find the concentration by doing what? By doing the number of moles, 0.225, over the volume, which is 0.4, to get an answer of what? To get an answer of 0.5625. So this is the concentration or the molarity of OH minus in the final solution. Okay, so the next exercise 4, is going to be a bit more simpler. So what is the concentration of all ions present in 0.1 molarity of Na2CO3? So very simply, you're going to separate it into its ions, so Na plus and CO3 2 minus. As you can see, we have one CO3 2 minus, 2 negative and 1 positive. So to balance it, you will put A2 over here. Now you will say, if 1 Na2CO3 will give us 0.1 molarity, then 2 Na plus will give us 2 times 0.1, which is 0.2 molarity. And this is going to be 1 times 0.1, which is what? Which is 0.1 molarity, right? So that is it for exercise 4. Let's move on to exercise 5. They said, calculate the number of moles of all the ions present in 50 centimeter cubed of a 0.1 molarity Pb this solution. So first thing we're going to do is we're going to calculate how many ions are there in this. So we'll separate it into 2 ions, which is Pb2 plus and CH3COO minus. As you can see, it's not balanced. So to balance it, we're going to put A2 over here. Next thing we're going to do is we're going to change this into liters. So to change it into liters, you will divide it by 1,000. So 50 divided by 1,000, that is very simply 0.05 liters, and you have the concentration. So let's find the number of moles by doing N equals C times V. So number of moles is equal to the concentration, which is 0.1, times the volume, which is 0.05. So 0.1 times 0.05. That's going to be what? That's going to be 5 times 10 to the power of minus 3 moles, right? But how many ions do we have? In reality, we have 1, 2, and 3. So 2 plus 1, that's 3. So you're going to take the number of moles and multiply it by 3 to get what? To get 15 times 10 to the power of minus 3 moles. So that is it for this exercise. I think these are the only exercises I'm going to do. Then I'm just going to do the rest, which are the CQDs. So let's move on to CQD number 4. What does it say in CQD number 4? A sample containing 25 centimeter cubed. Remember to change it to liters by dividing by 1,000. So your answer is going to be 0.025 liters. You have the concentration of NaCl. What is the molar mass of NaCl? The molar mass of NaCl, actually I don't think we need it, was mixed with what? Was mixed with 75 centimeter cubed. Change it to liters, so 0.075 liters of a 0.02 molarity CaCl2. So this is our concentration. They said what? They said calculate the concentration of the Cl minus ions present in the solution. So how are we gonna do this? Very simply, first thing we're gonna do is we're gonna calculate the total number of moles of each Cl. So in order to do that, you will need to find the number of moles of this and the number of moles of this. So NaCl, how do you find its number of moles? It's very simply concentration times volume. So 0.2 times 0.025, it's gonna be 5 times 10 to the power of minus 3 moles. So if 1 NaCl gave us this much, then 1 Na plus is also gonna give us 5 times 10 to the power of minus 3 moles, and 1 Cl minus is also gonna give us 5 times 10 to the power of minus 3 moles. Okay, now let us do it for CaCl2. So let's find the number of moles of CaCl2. CaCl2 will give us 0.075 times 0.02 molarity, which is what? Which is 1.5 times 10 to the power of minus 3 moles. So if one CaCl2 gave us this, then one Ca2 plus is going to give us 1.5 times 10 to the power of minus 3. However, 2Cl minus is going to give us what? It's going to give us 2 times 1.5 times 10 to the power of minus 3, which is what? Which is 3 times 10 to the power of minus 3. Now that you have the number of moles of like the Cl ions in general, you're going to add them together. So it's going to be what? It's going to be 5 times 10 to the power of minus 3 plus 3 times 10 to the power of minus 3. So it's 8 times 10 to the power of minus 3. Now you have what? The total number of moles of Cl. What's the equation? N equals Cv. So we need to find what? The concentration of Cl. So since we have the total number of moles and we need to find the concentration, we're going to do N over V is equal to C. What is V? V is the total volume, which is this plus this. So 0.025 plus 0.075, which is 0.1 liters. Okay, now you will just do the number of moles, which is 8 times 10 to the power of minus 3 over the total volume, which is what? Which is 0.1. So the final answer is what? It is 0.08 moles. And very simply, that's CQD number 4. We'll move on to CQD number 5. A lab technician is used to prepare 500 centimeter cubed, which is what? Which is, you have to divide it by 1,000 to make it into liters. So 500 divided by 1,000, that's 0.5 liters. And then this is the concentration from what? From a 6 molarity. This is the concentration, H2SO4 stock. Explain how the technician can do this. So very simply, what we're gonna do is we're gonna find what is the volume like that we're gonna use from this like H2SO4 stock. In order to do that, we would need to find the number of moles used. How do you find the number of moles used? N equals C times V. So it's 0.5 times 0.5, which is what? Which is 0.25 moles, right? Now, we have the number of moles and we have the concentration. We need to find the volume. So N equals C times V. V equals N over C. So V is equal to 0.25 over 6. That is what? That is 0.042 decimeter cubed. Right? Now we have what? We have the volume that we should use, okay? Now using a burette, because the burette can measure this decimeter cubed, of course, change it into centimeter cubed. When you change it, you're multiplying by 1,000. So 0.042 times 1,000, that's 42. So you're going to be using a burette, okay, to transfer 42 centimeter cubed of 6 molarity acid, and you will place it where you will place it in a 500 centimeter cubed volumetric flask containing how many liters of water? Containing about 50 milliliters of water, and then add enough water till the top of the meniscus is tangent to the etched mark on the neck and shake well to homogenize. So basically, you will take 42 centimeter cubed from this, you will place it in a 500 centimeter cubed volumetric flask, and then you will get, like it contains 50 milliliters of water. Right, then continue adding water until it reaches until it reaches 500 centimeter cubed. Okay, so that is it for CQD 5. Let's move on to the next CQD, which is CQD number 6, grid. Very important if it's grid. They told us a solution, okay, is formed by mixing 1 liter, 1 molarity KCl, okay? So you have the volume and the concentration, with 1 liter volume and concentration of PbNO3(2). They told us what? They told us calculate the molar mass of PbCl2 that will form assuming complete precipitation. So they need to find what? The mass of PbCl2 that will form assuming complete precipitation. If complete precipitation occurs, that means there will be what? There will be either some excess or some limiting. Like in each case, excess limiting is the same thing. But excess for the one that remains, limiting is the one that is completely used up. So in order to do that, okay, we will need to first of all find what? We will first of all need to find the number of moles of PbCl2. How do we find the number of moles of PbCl2? Very simply, we have volume, we have concentration, we will be able to find it. So let's start with KCl. KCl. 1 KCl will give us what? 1 liter times 1 molarity, which is 1 mole. Separate into its ions, so K plus Cl minus. 1 K plus will give us 1 mole. 1 Cl minus will give us 1 mole. Same thing we're going to do for PbNO3. So PbNO3 2. 1 liter times 1 molarity will give us 1 mole. So I'm doing volume times concentration. Now separate into the ions, Pb2 plus and balance, so 2NO3 minus. Right, so if 1 mole of PbNO32 gets, if 1 PbNO32 is 1 mole, then 1 Pb2 plus is gonna be 1 mole, and 2 NO3 minus is gonna be 2 times 1, which is what? Which is 2 moles. Right? So they're saying what is the precipitate that will form? It is PbCl2 that will form. So what's gonna be used is Pb2 plus and Cl minus, whereas 2NO3 minus and K plus are what? They are the spectator ions, or the ions just that like they stay the same after the equation. So PbCl2 is what will form, right? So let's write the equation for formation of PbCl2. It's Pb2 plus 2Cl minus will give us what? Will give us PbCl2. Right, now checking the moles, we have to divide them by their coefficient. So we have 1 mole of Cl minus and 1 mole of Pb2 plus. So let's divide them by their coefficient. This is 1, this is 2, okay? To find which one is the limiting reagent. So for Pb, the ratio is gonna be 1 to 1, which is 1. Whereas for Cl, the ratio is gonna be what? It's gonna be 1 over 2, which is 0.5. Definitely 0.5 is smaller. That means Cl minus is the limiting reagent. Because it is the limiting reagent, that means Pb2 plus is in excess. So based on the ratio, we will solve the whole equation. So if only 1 mole of Cl is used, right, because we used 1 mole of Cl, okay, then everything will be based on that. So you're gonna multiply by 0.5 here, you're also gonna multiply by 0.5 here, and you're gonna multiply by 0.5 over here. So it's what? It's 0.5 moles of Pb2 plus, okay, plus 1 mole of Cl minus, because we're using 1 mole, is gonna give us what? It's gonna give us 0.5, my bad, let me just erase this. It will give us 0.5 moles of Pb. Yeah, what's this? It's not Pb, it's PbCl2. Guys, I'm half asleep, sorry. What is this that I'm writing? Okay, so 0.5 PbCl2. So let's find the mass of PbCl2 formed. It's gonna be 0.5. Where's my calculator? So in this case, it's gonna be 0.5 times the molar mass of PbCl2. First of all, what is the mass of Pb? The mass of Pb, let me find it 1 second on the periodic table. Pb. It is 207, right? So it's 207 plus what? Plus 35.5, which is the molar mass of chlorine times 2, because it's Cl2. You will get what? You will get an answer of 139 grams. So very simply, the mass of PbCl2 left was 139 grams. They wanted to what? To 2 significant figures. So how do you make it to 2 significant figures? 1.4 times 10 to the power of 2. So that is part A done. Now part B. They said calculate the molar concentration of all ions left. So again, we will take back the number of moles that we found previously. So K plus, Cl minus, Pb2 plus, and 2NO3 minus. This was 2 moles. This was 1 mole. This was 1 mole. And this was also 1 mole, right? So basically, because Cl minus was used completely, it was a complete precipitation, and it's the limiting reagent. That means it was used up completely, right? And we also used, you have to take this from before. If you remember, what did I open? Oops. Okay, ignore it. We also used what? We also used 0.5 moles of Pb2 plus, because it was what? It was Pb2 plus 2Cl minus gives us PbCl2, right? But we took it based on the limiting factor. So this is 1 Cl, and this will become 0.5 Pb, and this will become 0.5 PbCl2, right? So 1 mole of Cl minus was completely used, but we used how many moles of Pb2 plus? We used 0.5 moles of Pb2 plus, right? So because we used 0.5 moles of Pb2 plus, and for K plus and 2NO3 minus, they are spectator ions, meaning that it's not gonna change, okay? Now we have what? The number of moles of each one. So let me just close this. That means K plus is 1 mole, 2NO3 minus is 2 moles, and Pb2 plus is what it is, 0.5 moles. We will divide it by the total volume, which is 1 liter plus 1 liter, which is what? 2 liters. So for K plus, it's going to be 1 over 2, which is 0.5 molarity. For 2NO3 minus, it's going to be 2 over 2, which is 1. So NO3 minus, it's going to be 1. And for Pb2 plus, it's going to be what? 0.25 molarity. Okay, so that is it for this CQD. I'm not going to do any more exercises. We'll move on to CQD number 7. What does it say? A sample containing 25 centimeter cube, change it to liters by dividing by 1,000. So 25 divided by 1,000, that's 0.025 liters of NaOH solution, was added to neutralize exactly 20 centimeter cubed. Again, you will change it to liters by dividing by 1,000, so 0.020 liters. And this concentration is 0.20 molarity concentration. They're looking for what? The concentration of the base. So we have the acid, HCl, we have its concentration and its volume. Here we have only the volume, we need to find the concentration of the base, very simply. When they say neutralize, that means there is no limiting and no excess. So let us make the equation. Very important step to make the equation, don't forget this, okay? Very important step. So it's gonna be 1 NaOH will react with 1 HCl to form what? To form NaCl plus H2O. As you can see, it's balanced. There's no need to change anything. Of course, if you needed to add 2, you would add 2, but for now it's balanced, okay? This is what matters for us. As you can see, it's what it is from a 1-to-1 ratio. What does this mean? That means the number of moles here is equal to the number of moles here. So number of moles of NaOH is equal to number of moles of HCl, right? So how do you find number of moles? It's concentration times volume. So it's going to be 0.025 times the concentration is equal to 0.020 times 0.2, right? 0.020 times 0.2, that's going to be what? 4 times 10 to the power of minus 3 is equal to 0.025 times C. So divided by 0.025, you will get an answer of what? C is equal to 0.16 molarity. That is it for question number 7. We'll move on to question number 8. So what did they say in CQD number 8? What volume, okay, the volume is, we need to find it, V, of this concentration, 0.50 molarity HCl, is needed to neutralize, important, very important, exactly 20 centimeter cubed. Of course, change it to volume, so it's going to be 0.020 liters. And you have the concentration 0.02 molarity, and you have this. First thing we're going to do is what? Is we're going to create the equation. It's going to be HCl plus CaOH2 will give us what? Will give us CaCl2 plus what? H2O. As you can see, it's not balanced. In order to balance it, you'll put a 2 over here and a 2 over here. So you can see what the ratio is, 2-to-1. That means 2 times the number of moles on this side is equal to 1 times of the number of moles on this side, right? So what does this mean? This means that 1 mole of CaOH, or like basically 2 times the number of mole of CaOH2 is equal to what? Is equal to 1 time the number of mole of HCl, right? So what does this mean? This means it's gonna be 2 times the, sorry for the colors by the way, wow, 1 second. It's gonna be 2 times CaOH2, which is what? Which is 0.020 times 0.020, okay, is equal to what? To the number of moles of HCl, which is 0.5 times the volume, right? So 2 times 0.020 times 0.020 is going to be 8 times 10 to the power of minus 4 is equal to 0.5 times volume. Move this to the other side, divided by 0.5, you'll get 1.6 times 10 to the power of minus 3. This is in liters. So this is in liters. If they want it in centimeter cubed, you will multiply by 1,000 to get an answer of what? To get an answer of 1.6 centimeter cubed. So that is it for CQD number 8 grid. We'll move on to CQD number 9. It seems like they solved it for us. But assign oxidation numbers for each element in the following chemicals. What do you need to know about oxidation numbers? First of all, if it is H, okay, it is then what it is +1 if it is with non-metals. But if it is with metals, it's gonna be what? It's gonna be -1, right? So H, if it's with metals, it's gonna be -1. With non-metals, it's gonna be what? It's gonna be +1. Oxygen is a very different case. We have a couple of considerations to take in for oxygen. Oxygen usually is what? Is -2, unless if it's hydrogen peroxide, which is H2O2. If it is hydrogen peroxide, then it's going to have an oxidation of -1. This we're talking about oxygen. Okay, and another case we have is that if it is with fluorine. Okay, so if it's OF2, okay, it will have an oxidation number of what? Of +2. Now, honestly, you could memorize all of them like this, okay? And you could make your life much complicated by memorizing, or you could go the easy way. What's the easy way? It is to find the charge, because we know that each one is it has this oxidation number due to its charge of electrons. Right? So let's take this for example, H2O2. Take them into their ions. In this case, it will be H2 plus. O2 minus. Simplify them. How can we simplify them? Because they both are 2, then you can cancel them out with each other, so you will be left with H plus and O minus. H plus means +1, minus means -1. Take this one for example as well. It's O2 plus and F minus. So 2 plus is +2 and minus is -1. Take this one as well for example. You can have Na2 plus and O2 minus. Simplify. Na plus, O minus. So minus, this is +1 and this is -1. Now, when it comes to big numbers like these, here's where you have to use the memorization skills. So hydrogen, you know it's always +1. Oxygen, you know it's always -2. So what is the total charge of this compound? That is 0. So +1 minus 2 plus x is equal to 0. So -1 plus x is equal to 0. So x is equal to 1. Same thing here. Here, because it has a charge, what you could do is you could memorize, and you could say, okay, carbon, I don't have it memorized, it's x plus what? 3 times -2 is going to be equal to what? It's going to be equal to -2. So x plus 6 is equal to -2. X plus -6, my bad. So x minus 6 is -2. Move this to the other side, so x is equal to 4. And oxygen, of course, is -2. Here's this one. You could do it. This is a bit complex, but look how you could do it. You could first of all separate them into their charges. You have Cr3 plus and SO4 2 minus. That means Cr has directly a charge of what? Of 3 plus. Then you take this on its own. S, you don't know it. It's x, okay? X plus 4 times -2 is equal to -2, right? So x minus 8 is equal to -2. Move this to the other side. X is equal to what? X is equal to 6. So S is 6 and O is -2. And same exact thing goes for this one. You could separate them into their ions. But this is going to be a bit more complicated. Why? Because we have a charge. Okay, so in this case, this is a case where you'll have to use your senses. And you have to solve it normally. So X for Cu plus N. If you look at the periodic table and you find nitrogen, you will find that it is where it is. In the 5th column. In the 5th column, their oxidation number is what? It is -3. This is one way you could also memorize it. Plus 3 times 1 is equal to what? Is equal to +2. Right, so this will be x is equal to 2. Very simply. This is how to solve CQD number 9. We'll move on to CQD number 10. Ooh, big question. What does it say in CQD number 10? They said, the mass percent of iron in a soluble iron trioxide compound is to be calculated using a titration based on the balanced equation above. Identify the oxidizing and reducing agents in the equation above. Explain your answers using oxidation numbers. Okay, so they want us to find what the oxidizing agent means, what undergoes reduction or gain of electrons. Let's say gain. And then the one that's the reducing agent, the one that undergoes oxidation, and it is the one that loses electrons. Okay, so basically for this case, we need to find the oxidation number for everything before and everything after, okay? So let's start with Fe. Fe originally has an oxidation number of +2. If you go to the other side, it has an oxidation number of +3. So what happened? It is what? It is losing electrons. So as soon as you see that it's losing electrons or it's gaining a positive charge, like the positive charge is increasing, that means it's losing electrons, right? That means it's undergoing oxidation, and if it's undergoing oxidation, then what? Then this is the reducing agent. So Fe 2 plus is what is the reducing agent. It went from 2 plus, it became what? It became 3 plus. Now, let us check MnO4 minus. If you check this oxidation state of Mn, okay, so let's see Mn. So for this one, it's gonna be x plus 4 times minus 2 is equal to minus 1. So x is equal to 7. Here it's plus 7, okay? And here oxygen is minus 2, of course. Or not minus 2, minus 8, my bad, minus 8. And here this is plus 8. Okay, you come over here, it becomes what? It becomes 2 plus. So if Mn was originally plus 7 and it became 2 plus, that means it's what? It gained electrons because it's becoming a smaller number. The smaller the number it becomes, that means it's gaining electrons. And if it's gaining electrons, then we say what? That it is the oxidizing agent. So it is what? Mn, okay? O4 is the oxidizing agent. MnO4 minus. So it went from plus 7, became what? It became plus 2. That's part A done. Let us move on to part B. Describe the color change that will occur in the flask when the endpoint of the titration has been reached. Explain why the color change reaches this point. Okay, it says what? The mass of sampled iron is carefully measured before the sample is dissolved with H2SO4, right? Okay. So in part B, they are saying what? They are saying describe the color change that occurs in the flask. We have what? We have Fe2+. Fe2+, its color is what? Is pale green, right? Then we also have what? We also have MnO4 minus, which gives what? A pinkish color. Now, in the beginning, it will change from what? It will change from a pale green to a pinkish color. This is due to the domination of the MnO4 minus. So it will go from an originally pale green all the way back to what? To a pinkish color. Okay, so that's part B done. We'll move on to part C. What effect will adding less aliquot V have on the experimental determined value of the mass percent of iron in the compound? What did they say about aliquot? Where is V? Okay, so basically, okay, so V is what is the volume. They said what effect will adding less volume have on the experimental determined value of the mass percent of iron in the compound? So adding a lesser volume will cause the percentage of mass of iron to be too small. Why is that? That is because the volume is too small, right? So if the volume is too small, okay, then that means the number of moles of MnO4 minus is too small, and the number of moles of Fe2 plus is also too small. So that's why it's gonna be what? It's gonna be a decrease in the mass, or it will be way too small for the mass to be even known. Okay, so they want what? Justify your answer using mathematical reasoning. So we know what? We're gonna take their ratios, right? So what is the ratios? The ratios is the number of mole of Fe2 plus over its coefficient, which is 5, if you look up and see, is equal to the number of moles of MnO4 minus, okay, over its coefficient. If you go up and see that, it's gonna be 1, right? So we know that number of moles is what? Number of moles is mass over molar mass. So we can very simply write mass over molar mass times what? Times 5. Okay, but here there's a bit of a trick. They said use M as molarity. I think I will use C. Okay, just to continue solving properly, right? So mass over molar mass, we know that first of all it's coefficient over, number of moles over coefficient. So that's 1 over N over 5. And we know number of moles is what? It is mass over molar mass. Whereas for the MnO4 minus, right, we have its concentration. So it's gonna be what? It's gonna be concentration, C times the volume. Now basically we're gonna do cross multiplication. It's the mass times Fe2 plus is equal to what? Is equal to concentration times volume times molar mass times 5. Okay, so now here is the important step. On one side you're gonna divide by what? You're gonna divide by the total mass, so mass total. On the other side you will also divide by the total mass total. You will multiply this side by 100% and you will also multiply this side by 100%. So if we're finding V, right, we know what C is, we know what the molar mass is, we know what mass total, and we know what mass is. We're looking for what? We're looking for V, the volume. Okay, they're saying if V is less than what is needed, so if V is less than what's the correct value needed, right, then definitely the percentage by mass is it's gonna decrease. Okay, so that was it for CQD number 10. We'll move on to CQD number 12. I think they answered it, no? Yeah, very funny. They have the answers over here. Okay, let's just see it together. What volume in milliliters of a 0.10 molarity, this is concentration of potassium permanganate is needed to completely oxidize 10 milliliters. This is the volume. Change it into liters by dividing by 1,000. So that's going to be what? That's going to be 0.01 liters of 0.30 molarity. This is the concentration of CuNO3. And they gave us what? They gave us the equation. First thing we're going to do is what? Is we're going to find the number of moles of CuNO3, which in this case is the Cu+, and it's going to be what? And we're going to make it in a relation to what? We're going to make it in a relation to the number of moles of MnO4-. But basically, as you can see from over here, 5 moles of Cu+ is going to give us what? Is going to give us 1 mole of MnO4-. That means very simply, 5 times the number of moles of MnO4- is equal to what? 1 times the number of mole of Cu+. Again, you're gonna take, only gave us Cu+ and MnO4-, right? So 5 Cu+ is gonna react with 1 MnO4-. That means 5 moles of 5 number of moles of MnO4- is equal to 1 number of mole of Cu+. Okay, so how do we find the number of moles of MnO4-? It's gonna be what? It's gonna be 5 times the concentration, which is 0.10 times the volume. It's equal to 1 times the concentration of, not the concentration, sorry, the number of moles of CuNO3. How do we find it? It's very simply the volume, which is 0.01 liters, times the concentration, which is 0.3. So 1 times 0.01 times 0.3, that's going to be an answer of 3 times 10 to the power of -3 is equal to 5 times 0.1 times V. So now basically divide both sides by 5, you will be left with 0.1 times V is equal to 3 times 10 to the power of -3 divided by 5, which is what? Which is 6 times 10 to the power of -4. Now divide both sides by 0.1. Okay, so divide by 0.1, you're going to get an answer of 6 times 10 to the power of -3 liters. So it's 6 times 10 to the power of -3 liters, but they want it in milliliters, so you will have to multiply by 1,000. So when you do, you're going to get 6 milliliters. Then we have CQD number 13 top. One of the lab experiments grade 12 students do is a gravimetric analysis to find the mass percent composition in alloys. During such a laboratory session, students were given an alloy of lead and gold and were asked to find its mass percent composition. During such a laboratory session, students were given an alloy of lead and gold and were okay. So we need to find what? We need to find its mass percent composition, right? We have what? The molarity, 15 molarity, or the concentration, 15 molarity HNO3. We have what? Also the concentration, but in percentage, 5% NaHCO3. We have saturated KBr aqueous. We have distilled water. We have some graduated cylinders. We have beaker, dropper, stir, goggles, and safety gloves. They proceeded to prepare 100 milliliters of 5 molarity HNO3 solution, dissolve this specific gram of the alloy in the above formed solution. They filtered the resulting mixture. They added desaturated, I think it's not NaCl, KBr. They added desaturated KBr to the collected filtrate till no more precipitate forms, filter the resulting mixture, and they washed the collected PBCl to precipitate. What? I think they are on a totally different path here, because I don't know where they got PBCl2 from. I think it's supposed to be an ABr or something like this. Anyways, let's see. Dry the precipitate, find the alloy's percent composition. The volume of the 15 molarity HNO3 needed to prepare 100 milliliters of, first of all, change it to liters, so 100 milliliters divided by 1,000, you're going to get 0.1 liters of 5 molarity HNO3. So if it is needed to prepare, then definitely we will know that the number of moles before is going to be equal to what? It's going to be equal to the number of moles after. Right? So in this case, it's going to be the concentration times the volume is equal to the volume, which is 0.10 times 5. So volume times concentration. So after solving, you will get that V is what? V is 0.10 times 5 over 15. So V is 0.033 liters, but if you want to change it to milliliters, you will multiply by 1,000. And when you multiply by 1,000, it is what? It is 33.3 milliliters, right? So that is part A done. Part B, using only the material found on your bench, briefly describe the procedure to prepare the 100 milliliter of 5 molarity HNO3 solution. Include in your steps the apparatus used and any safety measures that must be taken. So the first and very most important step is to wear gloves and goggles, right? Okay. The second step is to use one of the two 100 milliliter graduated cylinders, measure the 33 milliliters that we found above, okay, of 15 molarity HNO3. So use one of 100 milliliter cylinder to measure 33.3 milliliter or 33 milliliter of 15 molarity HNO3. Right, so they said what? They said now use second 100 milliliter cylinder, and what will you do? You will do 100 minus 33. What is 100 minus 33? It is 67. So you will fill in 67 milliliters of what? Of water, of distilled water, right? Next thing you're gonna do is you're gonna put it into the beaker. You'll put the water into the beaker. Okay, and then after this, you're gonna put the HNO3 where? Into the beaker, and you will stir it. So first you will wear gloves and goggles. Use one of 100 milliliter cylinder to measure the 33 milliliter that we found over here of 15 molarity HNO3. Then you will use the second 100 milliliter cylinder to measure 67 milliliters of water, or the remaining. So it's gonna be 100 minus this. Okay, then you will transfer the water to a beaker, and then you will empty the acid into the beaker of water, and you will stir meanwhile. Okay, so we will move on to part C. What does it say in part C? The student did not find a 100 milliliter volumetric flask on the bench. Justify why the volumetric flask need not be used during the dilution process. Because graduated cylinders, they measure with two significant figures accuracy. So the measuring cylinders, or graduated cylinders, let's say graduated cylinders are more accurate, right? Since they are more accurate, that means for sure that it's gonna be better use. So it's better use. Why? Why is it more accurate? Because it measures with two significant figures precision, right? So two significant figures accuracy. Now we'll move on to part D. What does it say in part D? While checking the groups working, the teacher notices that one group has a spill of a few milliliters of 15 on their bench. The teacher immediately asks the group to clean it up using what is on their bench. Which of the provided liquids is the best option? And explain your answer. These are what? These are, sorry, not these. My bad. You have to go up and you have to see which liquid will be the best to use, okay? So you have HNO3, which is an acid. You spilled it where? You spilled it on the bench, right? But you also have what? You have an AHCO3, which is what? Which is a base. So you have an acid and you have a base. What does an acid and a base reaction do? It will make a neutralization reaction, so it will form water and salt. So very simply, you're gonna use the NaHCO3 because it's what it is. It's a base. It will neutralize the acid. Now we'll move on to part E. It said the student tabulated the results as shown below. Find the percent by mass of the alloy in the sample. Okay, so the answer key is on a whole different planet. Yeah, so ignore the answer key. It's on a whole different planet. I don't know what happened. Okay, so very simply we have what? We have the mass of the lead gold alloy sample, right? We also have the mass of the dry filter paper, which is 28.7520 grams. So we have what? We have filter paper and precipitate after 5 minutes in oven, after 5 more minutes, so that's 10, and after 5 more minutes, so 15 minutes in the oven. So what I suggest to do is what? Is to add the three of them and get their average, so 29.6720 plus 29.4623 plus 29.4622, okay? And you will divide it by what? You will divide it by 3 to get to approximately an answer, which is what? Which is 29.532. Now, this way is one way. Another way, which I believe would be more accurate, is to be what? To add the two most consistent results. So let's add the two most consistent results, or the two results that are the nearest. In this case, it's going to be what? It's going to be 29.4622 4623 plus 29.4622. Add them together, you're gonna get 58.9245 divided by 2. You will get 29.46225. So for sure, I think the second method is way more accurate than the first method. So definitely, it's preferable to take the two most closest and then add them and divide them, like take their average. Okay, we're gonna subtract this from the filter paper mass, so 28.7520. So 29.46225 minus 28.7520. You will get an answer of 0.71025 grams, right? So it's gonna be what? It's gonna be this over the alloy sample, which is 0.7584. So 0.71025 over 0.7584 multiplied by 100 because we're doing percentage, and you're gonna get an approximate percentage of 93. Where did I read 36? 93.65%. So that's it for part E. We'll move on to question number 14 top, which is the last question, thank God. During a lab session, a grade 12 class had some tablets on their stations. Now they're always saying grade 12 because this is technically grade 12 material. We're not supposed to be taking it, but it's fine. The teacher explained that these tablets contain mainly sodium fluoride, NaF, and some impurities that are water soluble. The students were supposed to determine the mass percent of F- in the tablets. One group of students decided to dissolve one of the tablets in 60 milliliters of distilled water, add to the above solution an excess of 0.4 molarity CaCl2, filter the resulting CaF2 precipitate, wash the CaF2 with distilled water, then thoroughly dry it, and then determine the mass of CaF2. All collected masses are tabulated below, right? So they said what? AI. They said write the balanced net ionic equation for the precipitation that occurred. What is it? It is a reaction between CaCl2 and NaF, right? So you're gonna take the net ionic equation. That means the only ions that will react to form a solid. What is the solid in this case? It is CaF2, solid. That means what are the two ions that reacted? It's Ca2 plus and F minus, but as you can see it's not balanced, so you will put a 2 over here. That's part I done. Part II. Why is the net ionic equation a better way than other representations? Because it only includes the reacting species. It ignores the spectator species. What are the spectator species in this case? They are Cl minus and Na plus. So we'll move on to part B. It said why did these students repeat the drying and weighing step? Of course, you have to repeat the drying and weighing step because the obtained mass will keep on changing. So you have to keep on repeating it as long as the obtained mass keeps on changing. So, for example, first time you do it, you will have 55. Second time, you'll have 54. Third time, you'll have 53. And then it will be 53.9, 53.8, 53.7. Then it stays 53.7. When it stays 53.7, then you will know that there is no more extra and no more missing things. Right, so that means that all of the water could have been evaporated and you could stop heating it. So it's the pure solid or the pure thing you're looking for. Part C, what is expected to have a higher concentration in the filtrate? Na plus aqueous ions or Cl minus aqueous ions? Now, let's look at it from this side. And let us find the number of moles of each of them, right? So, we're dealing with CaCl2 and NaF, right? Which one did we add in excess? If you go up and you continue, and you read, you will see that which one was added in excess. You added an excess of CaCl2. So this is the keyword we're looking for. Excess of CaCl2. As soon as you see this, you will know what? You will know that the concentration of Cl minus is definitely for sure going to be greater than the concentration of Na plus because it is in excess. My voice is gone. Sorry for that. Part D, determine the percentage of F minus by mass in the tablet. Okay, so what is the mass of CaF? It's gonna be the very last mass recorded, which in this case is 1.745 grams, subtracted from the mass of the dry filter paper, so 1.462. That's gonna be what? 1.745 minus 1.462. That's gonna give us an answer of what? 0.283. Right, so let's find the number of moles of CaF. We have the mass 0.283 over the molar mass of CaF. Calcium, it is where can we find calcium? it has a molar mass of 40, plus fluorine. Fluorine has a molar mass of 19, right? So, but don't forget to do the times 2. So it's gonna be what, 3.63 times 10 to the power of minus 3. Okay, so now we have what? We have the number of moles of CaF2. But if you remember from the balanced equation, it was Ca2 plus 2F minus. It's gonna give us what? CaF2. Very important. How many do you have? How many F minus do you have? You have 2 F minus. So very simply, the number of moles of F minus is equal to 2 times the number of moles of CaF2. So very simply, the number of moles of F minus, it is 2 times 3.63 times 10 to the power of minus 3. So it's gonna be 7.26 times 10 to the power of minus 3. Okay, this is the number of moles of F minus. Okay, so what is the number of moles of F minus? It's 7.26 times 10 to the power of minus 3. How do you find the mass of F minus? Very simply, the mass of F minus is going to be the number of moles times the molar mass, which is what? Which is 19. So you will put it on the calculator and you will get an answer of 0.138 grams. You're rounding it, of course. So now we stop. We have what? We have the number of moles of F, which is 0.138 grams. 0.138 grams over the total mass of the NaF tablet, which is 0.522, and you will multiply it by 100, so times 100, you will get an answer of 26.4%. That was part D, if I'm not mistaken. Now part E, what does it say? It says a second group followed exactly the same steps but decided to dissolve the tablet in 100 milliliter of distilled water instead of 60 milliliter. How will this change affect the percentage of F minus by this group? It will stay the same, okay? Why? Because the extra water that is found in the F minus will be removed from what? It will be removed from the drying, right? So nothing is gonna change, it's just extra water. It can go from the drying, right? Now finally, part F, a third group of students decided to follow the same steps using 0.5 molarity of essence this instead of this. Will the third group be successful knowing that the constant is a very small number? So this is what? This is the equilibrium constant of SCF3, right? So because it is a very small number, right? That means SCF3 will what? SCF3 will form a precipitate, okay? Because it will form a precipitate, then that means for sure it's gonna be successful. Okay, so if it forms a precipitate, because the whole point of this is to find the mass of the precipitate, right? So because it has a very low constant, that means it will form a precipitate, that means it is what? It is successful. We'll move on to part 2. It said the third group were given a tablet to run their experiments. The balance they used measures masses to the nearest 0.01 grams. Will they be able to report the mass of the precipitate to 3 significant figures? Explain. So very simply, if you remember from above, the number of moles of F minus was what? It was 7.26 times 10 to the power of minus 3 moles, right? So it's gonna be the same exact number of moles, okay? But in this equation, if you pay attention, you will see it's SC3 plus and F minus. So to balance it, you will need to have 3 F minus. So you're going to divide it upon 3 F minus particles. So 7.26 times 10 to the power of minus 3 over 3. You will get an answer of what? Of 2.42 times 10 to the power of minus 3 moles. Right? So this is the number of moles of 1 F minus in this chemical. We will multiply it by what? We will multiply it by the molar mass of SCF3. So look up at your look at your periodic table, not up. For me it's up, that's why I said that. It's gonna be 44.9, so basically 45 plus what? 3 times the molar mass of fluorine. So 3 times 19, okay? It's gonna give you an answer of 102, okay? So it's gonna be 102 times 2.42 times 10 to the power of minus 3, and you will get an answer of what? You will get an answer of 0.24684, okay? So, they said what? It will report to the nearest 0.01 gram. That means it could be what? To this, it could be only 1, 2, 3. So it will stop at this point over here, so it will report only how many significant figures. 2 significant figures. So for sure, no, it's not going to be able to report the 3 significant figures. So for sure, it's not going to be able to report the 3 significant figures, because to the nearest 0.01 grams, it's going to be 0.24. So for sure, not. So thank you guys for watching. That was the end of chapter 4. A long video, I know. I'll try to shorten it in the editing, but I hope you guys enjoyed.